Welcome. Now we are going to see about evaluating with different learning rules. So this is a general neural network. We have x1 to x1 are the input neurons, w1 to wn are the weights, bias b, and we have an activation function here with the output y. So u equal to x1 w1 plus x2 w2 up to xn wn plus b into 1 into b. So V equal to U plus B, it is sigma xi wi plus B. There are two types of activation functions, threshold and sigmoid activation function. Sigmoid activation function formula is y1 equal to 1 by 1 minus e power minus av, a equal to 1. And threshold activation function is we have a threshold value. If the output V is greater than or equal to the threshold value here 0, then y equal to 1, y is the final output. If not else, y equal to 0. The learning rule, 5 types are there. So in the error correction learning rule, we are going to see set the initial weights 0, xi equal to si, yn equal to sigma xi wi. Sigma xi wi is this y. Y equal to function of yin. The error value t equal to y desired minus y which we got. Desired y value minus the obtained y value is the error value. Wi new is wi old plus xi t alpha. Alpha or a is the learning rate, t is the error, xi is the input and old weights. If stopping criterion does not satisfy, go to step 2. Develop a simple neural network model. We go for the program clear and closed. N equal to input, enter the number of inputs, then x equal to generate random number, the formula is lower bound plus random into upper bound minus lower bound. So the values between minus 1 to 1. So lower bound is minus 1 here plus rand of 1 comma n into upper bound minus lower bound. So 1 minus minus 1, 2. So here 2. W equal to minus 1 plus rand of 1 comma n into 2. B equal to rand of 1 comma 1, number of rows and number of columns we are generating. B is one value only. A random number is generated. For W, random numbers are generated. Display the input value, weights value and bias value. U equal to 0 initially. For I equal to 1 to n, U equal to U plus xi into wi and V equal to U plus B. So the neural networks formulas we have given. We are using threshold activation function in this one. So if yv is greater than or equal to 0, y equal to 1, else y equal to 0. If we use sigmoid activation function, y1 equal to, we will have some other variable y1, 1 by 1 minus x power minus v. If y1 is greater than 0.5, y2 equal to 1, else y2 equal to 0. Display the threshold value. Output of threshold activation and sigmoid activation function are displayed. So when we go for the program, so this is the program. We need to enter the number of neurons. So we'll go for the console. Run the program. So I'm giving the number of neurons as 2. So input values, random values are generated, weight values, output for threshold activation function and output for sigmoid activation function we get. And then we'll go for the same one with the AND OR gate, AND and OR gate here, AND gate, OR gate, logic and AND NOT gate. So update the weights and bias for the target AND gate. So it is 1 0 0 0 1 1 0 1 1, right? So everywhere you put a 1 value between bias, capital B values 1, right? So the inputs are 1 0 0 1 0 1 1 1 0 1 1 1. So now we're doing for AND gate. If OR or AND NOT gate is asked, you have to do in this way. And then Y is 0 0 0 1, desired output. And display the input value, display the desired output value. W equal to rand of 1 comma 3. Initialize the weights to random numbers. W1 equal to W, learning rate alpha or A is 0.5, flag is 0, epoch is 0, net equal to 0. While flag is equal to 0, do stop when actually we are stopping this from this, no? While flag is equal to 0 only, we are going to proceed this. So the stopping criterion is when the actual output we have got is equal to the desired output. So for I equal to 1 to 4, j equal to 1 to 3, 4 rows and 3 columns, net equal to net plus xi into wi. Step 3 of the algorithm. If net is greater than or equal to 0, y equal to 1, else y equal to minus 1. Error is the desired value minus the obtained value. So if error is equal to 0 also, target equal to desired minus actual output. W new equal to W volt plus alpha Tx, right? So error value into learning rate into X value. Display all the values. Continue for more epochs. If the epoch is greater than 1000, so still we haven't come to the stopping criterion, so display story and break. If y equal to y of 1 comma 1 is y desired of 1 comma 1 is equal to the achieved y of 1 comma 1, and y desired of 2 comma 1 equal to y of 2 comma 1, and y desired of 3 comma 1 equal to y of 3 comma 1, and same way for 4, flag becomes equal to 1 and end. So we are going to do the process only when flag equal to 0. So now when all 4 targets are achieved, flag becomes equal to 1 and we break it. Display all the weights. So we go for the main program. So this is the program type in Scilab. So in the console window we have the initial random weights, final weights, and learning rate is 0.5. Thank you.